Section 10.2b, Gauss-Jordan elimination and reduced row echelon form. We looked at row echelon form, in which case we ended up with essentially a diagonal of ones with zeros down to the left and any numbers we wanted to the right. And then of course we had our adjoining column of numbers. In reduced row echelon form, what happens is we end up with a pure diagonal of ones and then zeros. So it has two characteristics that we want to be concerned with. First of all, it is in row echelon form. So we need that diagonal of ones with the lower left corner zeros. And then furthermore, each entry above a leading one is also 0. For example, we have this form here, which we can change into what we would consider reduced row echelon form. And this is how we would do that. We now use the leading one down here to get rid of the numbers above it. So we're going to take 7/5 times row 3 plus row 2 and make that the new row 2. This means row 1 stays the same, row 3 stays the same, 0 times 7/5 plus 0 is 0. 0 times 7/5 is 0 plus 1 is just 1. 1 times 7/5 times plus negative 7/5 is now 0. 1, okay, so this one I'm going to work out below. You get 1 times 7/5, which is 7/5, plus negative 22/5. This gives us 7 minus 22, which is negative 15/5, which equals negative 3. We get a negative 3 here. Now I'm going to use this one to get rid of this 2 up here. So I'm going to take negative 2 times row 2 plus row 1, and that will be my new row 1. So row 2 and row 3 are staying the same. I take 0 times negative 2 is 0, so that doesn't change anything. 1 times negative 2 is negative 2, plus 2 is 0. 0 times negative 2 is 0, plus negative 1 is 0. That doesn't change anything. And negative 3 times negative 2 is a positive 6, plus negative 8 is negative 2. And we have one more move to make. We need to use this one to eliminate that one above it. So I'm going to take row 3 plus row 1, and that becomes my new row 1. So row 3 stays the same, row 2 stays the same. But now I'm going to do 1 plus 0 is just 1, 0 plus 0 is 0, negative 1 plus 1 is 0, negative 2 plus 1 is negative 1. There it is. The wonderful thing about reduced row echelon form is I can just simply look at my matrix and see that x equals negative 1, y equals negative 3, and z equals 1. Thus my solution is negative 1, negative 3, and 1. A little bit of a long process, but worth it when we can come up with this solution. And as I mentioned, this form makes it easy so that we no longer have to do back substitution. We've already solved for each variable. This process is called Gauss-Jordan elimination. So let's look at another example using Gauss-Jordan elimination.